Okay, let's dive into this really fascinating idea of making AI smarter. Common sense tells us if you want a better answer to a tough problem, you should probably just think about it longer. And you think the same thing applies to AI, right? More compute time should mean a better, more thoughtful answer. But what if that's not always true?
This might sound like a trick question, but get this. Some incredible research from Google, working with universities like USC and UCLA, has found a pretty shocking answer. It turns out that sometimes giving an AI more time to think can actually, well, majorly backfire. So the core idea they were playing with is called test time scaling. Just imagine you ask an AI a really hard question. Instead of it just blurting out the first answer that comes to mind, you give it extra juice, more processing power, to lay out its reasoning step by step. This is called a chain of thought. It lets the AI break down the problem, weigh its options, and even correct itself, all without ever changing the underlying model. Now, you and we probably think that more thinking time is always a good thing. It helps us catch silly mistakes, right? But the data these researchers found reveals a crazy twist that just turns that whole idea on its head.
Yep, you heard that right. The researchers discovered that in some situations, the more reasoning steps an AI takes, the higher its error rate gets. They came up with the perfect name for it: overthinking. The model literally gets lost in its own chain of thought and thinks itself into a dead end.
And wow, this chart just lays it all out there. Take a look. With a short thinking time, the error rate is pretty low. That makes sense. But then, look what happens. As the chain of thought gets longer, as the AI thinks more, the error rate actually climbs. That is the overthinking paradox in action.
Okay, so if more thinking isn't the magic bullet, what gives? What is going on here? Well, the secret, as it turns out, isn't really about the thinking process itself. It's all about how the AI was prepared for the test in the first place.
So this is the crucial point. The quality and, even more importantly, the kind of data the AI was trained on, that's what decides if a longer chain of thought is a good thing or a bad thing. It is all in the prep work. And this slide just nails the point. On one hand, if you train an AI with the right fundamental skills for a new problem, giving it more thinking time is like giving it a map and a flashlight. It helps it put the pieces together and find the right path. But on the other hand, if you test it on something it was never prepared for, it's totally lost. It doesn't have the right tools, so more thinking is just more wandering around in the dark. So that brings up a good question. How do we even define what makes a task hard for an AI? To really get to the bottom of this, the researchers came up with this brilliant way of thinking about an AI's abilities as a collection of different skills. Okay, so picture this. An AI's knowledge is like a giant toolbox. Inside, it's got tons of different tools, and each tool is like a specific skill. In their mathematical model, these skills are represented by something called eigenvectors. And, just like with a real toolbox, the AI is way better at using some tools than others. That strength, its mastery of each skill, is indicated by its eigenvalue.
And using this toolbox analogy, the difference between an easy and a hard task becomes super clear. An easy task might just need a hammer and a screwdriver, a couple of skills the AI knows inside and out. But a hard task? Oh my, that's a project that requires the entire toolbox. We're talking about drawing on a whole range of skills, even those specialized ones the AI hasn't used as much and isn't as confident with yet. The researchers even came up with a formula to put a number on this. Now, don't worry, you don't need to break out a calculator here. The big idea is simple. This formula lets them quantitatively measure how hard a task is. A higher number just means the task demands a much wider, more diverse set of skills to solve correctly. And what's so cool is that this deeper understanding of skills and task hardness didn't just explain the overthinking problem. It pointed directly to the solution. It gave them a clear blueprint, a recipe for designing the ideal training plan for an AI. And here is that recipe. To build an AI that actually gets better with more thinking time, its training curriculum needs 3 key ingredients. First, diversity. It has to cover a wide range of skins. Second, relevance. The skills have to actually matter for what you want it to do. And finally, and this is key, hardness. You have to include difficult tasks to force the AI to build a really robust, well-rounded skill set. And you don't just have to take my word for it. Here it is, straight from the researchers themselves. This is their central conclusion, a really powerful statement that the key to unlocking an AI's true potential lies in how we strategically design its education. When they put this theory to the test, the results were definitive. The absolute best strategy was to create a training mix that heavily favored the harder, more diverse tasks. You can see the easy niche stuff got a much lower priority. This is how you build an AI that's prepared for real-world complexity. So, the crucial point we're left with is this. Building more powerful AI isn't just about throwing more servers at a problem and letting it think longer. The quality and the strategic design of the data it learns from is fundamentally more important. It's not about brute force, it's about building a better foundation through smarter preparation.
And this research really opens up a profound question for the future, doesn't it? If we now have a blueprint for how to curate data to build AIs that can reason more effectively, it forces us to ask, what kind of curriculum should we design? What skills matter most? And what are the complex problems we should be teaching our most advanced systems to think about next?